Welcome back to the video lecture series for Introduction to Data Programming using Scala. In this video we continue talking about the Java util concurrent package, and in particular we're going to take what we learned in the last video about executors and actually use it inside of a program. So last time we saw that we can create these executor services. We create them using the executors class, and the advantage of using an executor service, there are two main advantages. One is that we can use different executor services to control exactly how threads are created and when they're created and allow them to be reused. And the other is that we can use this callable, which has the ability to return a value, which our runnable did not. So I want to come and work on the multi-threading code that we've done previously. And to make this a fairly simple example, I'm going to use our good friend the Fibonacci function, and I'm going to write it, that should be a B not an N, I'm going to write it using recursion because, and this is one of the challenges in teaching parallelism, I want this to be kind of slow. I want to take advantage of the multi-threading. Though we're not really looking at speed up here, still if I write this so it's sequential, this thing happened, or if I write this so that it calculates it in an intelligent way instead of doing this particular problem recursively, it will finish almost too quickly. Okay, so there we have our recursive Fibonacci defined, and then we'll make a method to calculate Fibonacci's with an executor. So let's first start off by making ourselves an executor service. We'll call it ES. Now, what type of thread pool do we want? I'm going to use a new fixed thread pool, and let's say the machine I'm on nicely calculates 4 things in parallel. I need to import that, so I'll hit Control Shift O. It gives me some options for what's executors. I want the ones from Java util concurrent, and so we get a new import up here. Okay, so I have an executor service, and what I want to do is I want to have this run through and calculate maybe the Fibonacci numbers from 30 down to 15. So I'm going to start with the big one, the one that takes the longest to do, and I'm going to end with the small one that should calculate quickly. And I want to throw these off and have them done as calls on our executor service. Okay, so for I in 30 to 15 by -1, so we'll count down. I'm going to yield, and what I want to yield is the result of submitting a callable to our executor service. And we'll hit Control Shift O again, and here again there is also a version of this in Scala, but we want the Java version for now. And when you make a callable, it has to have a single method called call. The call method doesn't take any arguments, but it does need to return something. And in fact, the callable type has to take a type parameter. So what are we calculating? Well, we're calculating Fibonacci numbers, so I'm going to make it return an int. So each one of these is going to call submit. It's going to pass it a callable that calculates the ith Fibonacci number, where I runs from 30 down to 15. And remember, what submit returns to us is a future object. So what can we do with these future objects? And by putting these things inside of a yield in a for loop, I'm actually getting them back. Let's actually give these a name. We'll call it futures. Okay, so what can you do with a future object? Well, you can ask whether or not it's done. You can ask if it's been canceled. You can cancel it. The most important method that we're going to deal with is the get method. When you call get on a future, if you call this version of get, it simply blocks and waits until the task has been completed, and once it's been completed, you get back the value for it. It is also possible to call get so that it has a timeout, so that it will block and wait for a certain period of time, but if the result isn't available after that amount of time, it will continue going with the calculation. We're only going to deal with this first version of get, which simply blocks until the values are completed. And so what I want to do we'll see if I can do this with the underscore. I'm going to give it a name, F, for a future. Okay, so what I'm going to do here is for each one of these I want to print line out the value of f.get. We'll make it so our main calls this method, the calcfib with executor. And now if we run this, what we should get are the Fibonacci numbers, starting with the 30th Fibonacci number, which is large, and going down to the 15th. Now these are printed in order here because they're not printed, or because that's what this does. It runs through each of the futures and it calls get. This is not printing them in the order in which they are completed. It's printing them in the order in which they were set up in this collection. Another thing to note here, my application hasn't stopped. Okay? It's still sitting here running, and this is because it turns out executor services keep all their threads alive. Remember, this fixed thread pool is keeping its threads alive just in case we need it later. Having the main thread finish, so our main calls here, it goes in, it does this, it prints the results, and then it jumps back out, and the main thread terminates. But this executor service that we created in here is still keeping threads alive. So one of the other methods on the executor service is a shutdown method, where you can tell it, okay, I'm done using you, I don't want you to keep anything alive. And if we include that, now after printing, it terminates. Just to make it clear, I actually want to add a little bit of complexity inside of here and make it so that our call not only does the call, but it also prints it. So I'm going to print out the value that was calculated, and then I'm going to return it. So the fact that I have to print it and return it is why I had to put this inside of, or I had to make a val in here. And in addition to doing that, let's do put a little bit of formatting in there, just so that we can tell the prints from the calculations and how they are separate from the prints down here of the actual values, just in case they're interleaved, because we are multi-threading this. And indeed, one of these was interleaved after the first print. So the order in which they are calculated, as we would expect, because this is multi-threaded, does not necessarily correlate with the order in which they were given out. The first one did finish first, but because I made this a fixed thread pool with only 4 threads, these 4 all got queued up. And then after one of them returns, then it can do this one. Then after another one returns, it can do this one. So it's really not possible, for example, for this calculation, or it's very hard for that calculation to compete with this calculation, because they won't all be spawned at the same time. So because I only used 4 threads, the order in which they calculate is closer to the order from greatest to least. As you can see, there's a little bit of swapping around in there. If I were to increase the number of threads, so instead of going to 4, let's say I go up to 8, it's likely that that's going to cause my processing to happen in a less ordered. In fact, clearly in this run, the largest value, which was the first thread that we created, doesn't actually finish calculating until many others have gone. Here now it was the first 8. So 1, 2, 3, 4, 5, 6, 7, 8. So down to that, these were all spawned kind of at once, and then the others had to wait for some of those other threads to finish. So the first one that is printed has to be part of the first batch. By making it so that it's 8 long, we've reduced the chances that this first number is part of that batch. So anyway, this gives you a brief introduction to how you can use Executor services, how you can use the futures, and how you can get back values from them. And we're going to continue looking in the Java util concurrent package in the next video, where we'll talk about some of the data structures that they provide for you to make it easy to do common activities.